Hello everyone, today in this video we will know how to calculate the bar bending schedule of one-way slab. The dimensions of the slab are given as follows over here, so that please consider the question for the process of doing how much total quantity of steel is required. So now we will calculate the length of main straight bar. So here the main straight bar will be in this way. We are providing this main straight bar in the bottom. So there were two hook lengths, so that hook length will be 90. So here we will calculate the length. Firstly we will calculate how much length it would be. So length equals to 2500. So here the shortest span is given as 2.5 meters, which is 2500 mm, plus width of the supports here is given as 230 mm. So here you can see this is shortest span, which is of 2500 mm, and the width support is given as 230 mm. So this 2500 mm plus 2 into width supports, these two width supports, and we are deducting 2 into clear cover, which is we are taking clear cover for slab is 25 mm over here, so that we are after calculating of this we will get 2910 mm. So the total length now we will calculate. So this 2910 mm plus this hook length, here we are providing two hook lengths, so this plus into 2 into 9d. For one hook length we provide 9d, so for two hook lengths 2 into 9d. So this 2910 plus 2 into 9 into, here we are taking for main steel bars 12 mm we are taking in question, you can see. So that 2 into 9 into 12 if we do, we will get the total length as 3.3126 mm, which is 3.13 mm. So now we will calculate total number of bars required for this main straight bar. So the longer direction plus 2 into this width supports. 2 into width supports. To longer direction is given as longer span 6 meters. So 6000 mm plus 2 into width supports is 230 mm. And we are deducting clear cover at both ends. So minus 2 into 25. And we are providing this at 120 mm spacing. Here we are providing this at 120 mm spacing, here you can see, and these are providing by alternatively we are bending up, so that we have to take 2 into 120 plus 1. This is the formula. So after calculation of this we will get 27.708 numbers, which is 28 numbers. So now we will calculate the length of bent up bars. So length equals to this shorter span plus 2 into width supports minus we are directing the clear cover at both ends, so that we will get 2910 mm. And to calculate the bent up portion, the formula is length, total length equals to small l plus 2 into 90, because here you can see two bars are bent and the crank are bented up at two positions. So 2 into 90 plus 2 into this crank is given at 2 times. So plus 2 into crank के लिए the formula is 0.42 D we will take. So firstly we will calculate for D here. So D के लिए calculate करें तो here they have given in the question as a thickness of slab is 100 mm we have to consider. So 100 mm minus, and they have given top cover and bottom cover to be taken as 15 mm. So at both ends we are taking, no? So minus 2 into 15, and the steel we have to use here is 12 mm. So minus 12 we have to do, so that we will get 58 mm is the D value. So now we will substitute all these values in this formula. So L equals to 2910 plus 2 into 9 into, and the steel for here we are using is 12 mm. So 9 into 12 plus 2 into 0.42 into, here capital D value we have calculated, which is 58 mm. So after substituting this, after calculating all this, we will get the length equals to 3174.72 mm, which is 3.18 meters. Now we will do for number of bars required. So longer span plus 2 into width supports minus 2 into clear cover divided by 120 mm spacing. We are bending this at alternatively, so that we have to take 2. So after calculating this we will get 26.7 numbers or 27 numbers. Hello everyone. So here we will calculate the distribution bars at total length equals to distribution bars we will provide at longer direction, so that 6000 mm plus 2 into of width supports, and we are directing at end cover, clear covers at both ends. So minus 2 into 25 plus 2 into 9 into 6. Here you can see the bends are bent, two hook lengths are there. So 2 into 9 into 6 mm dia we are using, and the hook length is 9d. So after calculating this, we will get the length is total length is 6518 mm, which is up 6.52 meters. So now we will calculate the total number of bars required. So 2500 shorter span we have to take here. So plus 2 into width supports is 230 mm minus 2 into end clear cover. So 2 into 25 divided by, in question it is given as 160 mm center to center spacing. Here you can see, so that we have to take at 160 mm center to center spacing. This is not bending alternatively, so that we have to take directly 160 mm center to center spacing plus 1, so that we will get 19.1875. So the total number of bars required for distributions bar at bottom will be 20 numbers. So next we will go for top distribution bar के लिए. So that here you can see total length equals to 6000 plus same will be there because we are providing at same. So 2 into this 2 with the supports minus 2 into clear cover plus 2 into hook lengths. 2 hook lengths were there. So that 2 into 9 into 6 equals to 6518 meters, 6518 mm, which is approximately equals to 6.52 meters. The numbers will be here in question. They have given, we have to provide 3 numbers at the top at both ends. Here as this, they have to provide distribution bar 3 number of bars at both ends will be, then it will be 6 numbers. As per the question, we have to take top distribution bars will be 6 numbers. So here you can go through that as we have calculated already. So I was putting here over in the tables for easy calculation. So we, for main straight bar we got 12 mm bar के लिए 12 mm bar we have used. We got 28 numbers in after calculating over here, this 28 numbers, and the length is 3.13 meters. Here you can see. Then 28 into 3.13 if you do, we'll get 87.64. So this 87.64 into 0.89 if you do, the total weight required for this main straight bar for 28 numbers के लिए, we will get the total weight of steel is 80 kgs. In the same way, we have to put all the details which we have got over here. Like a main bent up bar के लिए, the structure will shape will be in this way. We are using 12 mm dia, and we got here 27 numbers is required. And in the same way, the length here we got is 3.18 meters. After calculating 27 into 3.18 if you do, we'll get 85.86. So 85.86 into weight this if you do, d square by 160.2 if you do, we'll get this weight, this one. So after doing this 2 into, we'll get 76.42 kgs of steel is required for bent up bars के लिए. In the same way, distribution bars bottom के लिए we are using 6 mm dia, and the numbers here we got is 20 numbers, and the length is 6.52 meters. After multiplication of 20 into 6.52, if you do, we will get this much, and after doing this into this, we will get this one 28. This is 13.4. So that we will get this one. Distribution bar के लिए 6 mm dia we are using, and numbers is that we got here, we have taken 6 numbers, and the length is 6.52. After multiplication of this, we will get 39.12. After this into if we do, we will get 88.61. After calculating of all these weights, we will get 193.72 kgs is required for the dimensions of this one way slab. So please go through the figure how we provide the bar bending schedule. So if you all like this video, please follow, like, share and subscribe to this channel. Thank you all, and if you have any doubts, please comment in the comment section. Thank you all.